So, if you're new to Blender, you might be wondering, how do I get the most out of it when it comes to rendering? That's what we're going to look at in this video, so let's get stuck into it. This is the start of a whole series on rendering, so don't worry if this doesn't go too deep into the weeds. Technically, we are going to get to that in some subsequent episodes, so do subscribe because there'll be lots of content coming out to help you render in Blender much better, more better. Alright, so we're jumping straight into Blender 3.6, and the first thing we're going to look at is the basic controls. Now you saw in the intro, if you press F12, then Blender should render a single frame. You should be able to tell which frame you're on as well by going to the bottom of the screen where the timeline is. Now your Blender layout may be different, so you need to find the timeline. Now you can create a new timeline anytime you like just by creating a split and then choosing timeline from the options. And then you can basically tell which frame you're on by looking here, or you can even change it. You can type it in if you want to render a different frame. All you have to do is punch in that number, and then you can press F12 again, and you'll see that you start rendering whatever frame that you've asked for. You'll also get some other information like how long the render's been going, how much time's remaining, and how much memory's been used. These stats can be helpful. You can choose different slots, and then you can render variations. So you can make changes to your scene, and then render, and you'll actually be rendering on a different slot, so you can actually go back and forth between the slots by pressing the number keys on your keyboard. Very handy if you're doing minor variations of something and you want to check how those minor variations work. So by default, Blender doesn't actually save a single image render for you. So even though you selected to render to file by pressing F12 or going to the render menu, it will not save the image. So the way around that is to bring up the image editor where the render is, go into the image menu, and then you can save the file. And it gives you all the options that you need. You can choose the format, you can choose bit depth, what channels to include, whether you want the Z buffer or not, all that kind of good stuff. So that's single frame rendering. The other thing that we can look at is doing an animation render. So we can come up to the render controls, and you can see here, you can either do a render image, and it has the keyboard shortcut printed there, which is really nice, or you can do an animation. So if you press an animation, you'll see that you start rendering from whatever frame you had set as the start frame to the end frame. I'll show you where those controls are in just a moment. And you can see that now we're rendering frame 2. Some other things that you can see in this view, we can check different view layers if we added more than one layer to render. We're not going to do that today, that's a bit advanced. And you can also look at various render passes. Again, we will look at render passes today though, so stay tuned, that's coming up a bit later in the video. One last thing about the basic controls, and this is not really basic, but I thought I'd throw it in. You can actually script rendering. So if we go into Blender's scripting workspace, we have a console here and we can type in some commands, as well as a window where we can write scripts. Now I'm going to just give you the console command for today. So if you want to render in Blender using Python, you can type BPY to select Blender's Python module, ops to select the operators, render to select rendering, and then render to select the render operator. If you want to just mimic pressing F12, you have to type in invoked, default, not going to go into the details as to why, and then once you press enter to start that command, you'll do a single frame render of whatever frame that you've got currently selected in the timeline, and that's pretty much it. If you want to know more about scripting in Blender, be sure to drop a comment below and ask me your questions. Now we're going to look at how do you actually control things like the resolution of the image, how many frames that you're actually going to render, which frames do you start and stop on. There's a lot of controls. Let's go quickly through them and tell you what each of them does. So resolution is controlled not from the render properties panel, but from the output properties panel. So one down from render properties, and you can see here we can control the resolution. We've got 1440 by 1080. Also, this is a really handy multiplier. So this percentage field here, you can actually put in 50%, and then when you render, if I go to a different slot, if I go to slot 3, so if I render now, it renders at half the resolution. You can also play with things like aspect ratio. I don't usually do that though, you may have your own reasons. We also have render region. So if you only want to render a certain region, let's just say you wanted to render just this doorway here, I can press Control and B, and I can outline just that area. You'll notice it gets surrounded by a red dashed line. If I go back to the render and just press F12, you'll see that now only that small area of the screen is rendered. So let's just imagine that you had something wrong with that part of the image. You can use render to region in order to only re-render that part and then test until you get it right. So it's going to save you a lot of time. You don't have to render the entire image. You also have things like obvious things like the frame rate, which will control how many frames per second things happen at. You've also got the start and end frame of your animation, and something else which is kind of useful, which is the step. So imagine that you had maybe a 10-second animation. That's 250 frames at 25 frames per second, but you don't have the time budget to do a test render to render all 250 frames. You could set this to 25, and you'd render every 25th frame, meaning that you could preview your animation for 1/25th the total render time. So the step is really, really useful for just giving you a quick preview of what your animation is going to be doing. You can do things like figure out if you've got enough memory, for example, for all of the parts of your shot to actually fit into your GPU's memory or your CPU's memory. All that kind of stuff is really good for debugging so that you don't end up committing to an all-night render and finding that it breaks overnight because you didn't do this. Now, when it comes to outputting animation, you have to make a couple of important choices. One is, well, where do I want to put all the output? So this output location is really only for animation renders. There's a few options here, so I'm going to go through the important ones first, leave the rest for an exercise. You guys can basically look up these in the Blender manual. Hot tip, if you don't know what something does, you can either hover over it or you can actually go and click the online manual, and it should take you to the page in Blender's documentation that talks about that particular feature. So for example, file extensions, adds the correct file extension per file to the output files. Pretty easy stuff. So first we're going to look at the important choices. So we're going to choose a directory to put all of the rendered frames into. Choose a place which has enough disk space because, well, we'll talk about that in a moment. You do need to make sure you've got enough disk space because otherwise the render will stop. And when that happens, well, you're going to be like this. So one question you might have is, okay, I've selected my location, now what file format am I supposed to use? Well, I've left a link in the description below to this table. So Blender has provided a table that kind of gives you a bit of an idea about why you should use any of these formats for what you're doing. So I use OpenEXR quite a lot, and you can see here it's good for alpha, metadata, and DPI. I've linked to this resource in the description below. This table is just a real quick way to determine what each of these formats could be used for, and they also give us hint section, which is kind of nice. You might want to do a little bit more research, but basically this is a good place to start. If you've never touched file formats before, you can probably use OpenEXR, PNG, or JPEG based on the descriptions here. When it comes to rendering animations out, there is one big choice you're going to have to make, and that's whether you render to a video file output or whether you render to individual frames. Rendering to video can be very risky. If Blender crashes at any point, you will lose everything, even if you've been rendering for days, and then you'll be like, no! So if you don't want to be like Vader and you're suspicious that you may be pushing the envelope, then it may be safer to render to individual frames. That doesn't guarantee that you'll be pain-free either. The other big problem that you'll have is that you may run out of disk space. But the truth is, all of these things are within your control, and therefore, as I always told myself, 99% of the time when you experience pain, it's probably your own fault. Well, generally, it's a good idea to calculate how much disk space you need for your animation, and if you can't make that because you don't have enough room, then you either buy a bigger disk or you render to video, and you take the risk. Disk versus risk. So let's look at how you would do that. So rendering to video is as simple as coming into the file format window and choosing one of the container formats. I'm going to choose this one, FFmpeg, because then I have access to all of the encoding information. So I can choose the container, I could choose QuickTime, or I could choose, let's just go MPEG-4, MP4, and then I can choose the codecs. Blender has a vast array of them. I'm not going to go into these right now because there's just too much. If you are going to render to single frames, then it depends on what you're going to do. If you're going to be compositing in another program, you don't really have another choice. You'll have to use OpenEXR multilayer so that you can output all of the render layers and passes that you want to use. If, however, you're happy for Blender to do the compositing, then you can come down to post-processing, you can tick compositing, make sure it's selected, and then you can still render to video because Blender will do the compositing pass after the render pass. So render will happen, compositing will happen, then it will write the result to the video file. If you don't want to use Blender's compositor though, then you're kind of stuck rendering to OpenEXR multilayer. Now, this is where you really need to understand a little bit more about how much file space you need per frame, because you can actually get some really, really big file sizes. So for example, I did a comparison using the Italian flat scene from blender.org, And as you can see here, you can easily get north of about 150 megabytes per frame if you go nuts with all the render parsers. Now, before I go any further, I should probably talk a little bit about render parsers and what they are. So if we come up to the view layer properties, you can find all of the render parsers here. These are extra bits of data you can add to your render, such as how far into the image a certain pixel was. So let's just say I pick a pixel on this particular mesh here. The distance from the camera to that mesh would have been stored in the Z buffer, so I can actually have that information. That helps with compositing. I can also put position, normal, vector, UV, and a whole bunch of other different data sets that we can use in compositing to get all kinds of different effects. I'll do a separate compositing video if I get enough people shouting about it in the comments, because it is an interesting but quite complex subject all on its own. But that's what I mean by render parsers. Now, each of these is going to add quite a lot of data. So for example, for a 1080p frame, we can easily get up to 100, 180, almost 200 megabytes per frame. That's just 1080p. You can see how this can very quickly eat up disk space if you're not careful. So I want to show you one way you can get around that. If you're not going to be doing some very heavy compositing, then you have some other choices as to the compression you can use, and some of these are a lot better than the default. The default is zips lossless, which basically gives you exactly the same data as you would have without compressing the file, but it is compressed, so it'll be less data. You can actually do a lot better in terms of file size, but you will be sacrificing some accuracy. So there are a few different compression codecs that I've benchmarked. I did Pixar 24 and also DreamWorks Animation A. And you can see how they perform on this graph. So blue is zips S, which is compressed but using lossless compression. Then we have in red, we've got Pixar 24, and then in yellow, we've got DreamWorks Animation A. Looking at the files side by side, you really can't tell any difference. There's almost no point showing you because there is nothing to show. There is a big difference in the file sizes though. You can see here that DreamWorks Animation A, on average, can reduce the file size by almost half. In some cases it's a lot better, in some cases a little bit worse, but it does perform really well. Like for example, in diffuse color, it is a heck of a lot better than either Pixar or Zips. And in some cases it doesn't perform as well as Pixar 24, so it depends. Also, you'll notice that some parsers are a lot bigger than others, so denoising data tends to be quite large. So if you're not using denoising, then you might not need that one. However, most people are probably going to be using it for the fact that it helps keep your render times down. So do make sure you budget for enough disk space for it by doing some tests before you commit to your all-night render so that you don't run out of disk space. Quick word about the image sequence settings. You'll see here we've got overwrite and placeholders. So this is really useful if you are rendering an animation to image files. If for any reason your render stops or you decide to stop it and you want to continue rendering from where you were left off, then you can turn overwrite off because it's on by default. So for example, I have rendered a few frames. I've rendered up to frame 4. If I was to start rendering this animation again, I'll just show you that. If I press Ctrl F12, you can see it starts rendering at frame 1. Not what I want if I want to continue from frame 5. So if I turn overwrite off and then I go and press Ctrl F12 again, you can see it starts rendering from the next frame. Now I don't need to actually go into Blender's settings and tell it to start rendering from frame 5. So this is a nice way of just making sure that you don't overwrite work that you've already rendered. So if you get into the position where you're going to be doing a lot of rendering, maybe re-rendering, you may want to turn overwrite off so you don't accidentally destroy work which you're happy with. Placeholders is really useful if you want to have a kind of cheap and quick way to set up a render farm. If you've got multiple computers on a local network, you can set up a folder which is shared that all of the computers can write to, and then what you do is turn overwrite off and placeholders on, like this. Each machine will then look at that folder and look for the next frame in the sequence that isn't already there, and it'll put a placeholder file there with the frame number that it's rendering to stop the other machines from duplicating the same work. This kind of works really well. The only thing you have to then synchronize is make sure the file is all the same. There's a whole bunch of other stuff which we happen to have written an add-on to help with. So if you're interested in distributed rendering or building a render farm, then do check out the links in the description below. We have an add-on which we've created which automates all of this, so you don't need to worry about it. So often the images you get out of Blender are a great start, but sometimes you might want to do something additional to that image. You might want to do some color grading, add some mist, add some other effects, or in this case, what I'm going to do now is remove noise. So we're going to use Blender's compositor and the post-processing capabilities to remove some noise from this image. So I have let this image render for about 20 seconds. Normally, if you were to open up this file and hit render, it would render in about 8 minutes. That's on a RTX 2070. So in this image, I've got on the left the raw result that Blender rendered using cycles, and on the right, I've got the result of my compositing network. So the first thing we're going to need is we're going to need to turn on compositing. So you do that by coming up here and adding a workspace, compositing. I've already got one set up, and then click Use Nodes. The other thing that you want to make sure, just in case you might have accidentally turned it off, is come to the output properties, down to post-processing at the bottom, and make sure compositing is enabled. If you've turned that off, then it doesn't matter what node network you've got in here, nothing's going to work. Now this might look a little bit complex. I'm going to turn off the backdrop just for a second so it's a bit easier. Think of it like this. Render data comes in through the render layers node, which should be enabled by default if you start a brand new file. And you should be aiming to do something with that data and then output it to the composite node. The composite node is what we see when we hit F12. It's just that usually if there isn't a compositing network set up, you just get the raw result out of Blender. Okay, so data comes in, goes through your network, and then comes out. You can also add things like viewers so that you can actually see what changes do what to your image. Now, in order to use denoising, we're going to have to add some render layer passes, which may not be enabled by default. So you come over to your view layer and then scroll down to filter and expand it. It may be like this. So expand filter, make sure denoising is enabled. I'm actually going to show you what it looks like when denoising is not enabled and you use the denoising node. So let's just talk about that real quick. If you forget to add this rendering pass, well, this is what you're going to get as a result. And as you can see, it looks okay at first glance, but then we look at some of the details and they have been completely blurred out. Compare this to when we add the denoising data pass. You can see the details are much, much crisper, and there's not nearly as much of this blurring and smushing and smudging. Correction, denoising, not denoising data. So the denoising pass is actually enabled by default, and if for any reason you turn it off, you do get this loss of detail. Denoising data I'll talk about in a moment, and is related to the denoising node in the compositor and provides you a little bit of extra, I believe, accuracy. But the two are completely separate. Denoising is on by default, denoising data usually not, usually have to add it. So after you've enabled compositing and the denoising pass, you also want to make sure in your render properties that denoising is turned on. So go to the sampling section of your render properties, go to the section for render to file. Remember there's a different one for viewport rendering. And then come down to the denoise section, make sure denoising is enabled. And I'm going to be using open image denoising. And I like this because it works regardless of whether you have a GPU or not. It can use the CPU, so it's, I suppose, a bit fairer to everybody who's watching this video. So open image denoise, if you do have a graphics card, you can use optics, but optics applies its denoising directly to the image before it gets to the compositor, so you don't need to do anything. In fact, you probably wouldn't even need to use the compositor to denoise using optics, but not everyone has optics, so we're going to go ahead and use open image denoising instead. Alright, so let's take a look at this compositing network. It might look a little daunting to begin with. I'm going to turn the backdrop off, but really there's two parts. The bottom one actually has denoising on. You can see that because it has a denoise node, and the top one does not. They then go into a split viewer so we can actually see the difference between denoising and not denoising. The rest of the network actually belongs to this demo file. This demo file is actually showcasing the exposure node, which allows you to increase or reduce exposure of the image as if you were using a real camera. So we're not going to pay any attention to any nodes, but pretty much this one, the input and the output. The next thing I'm going to show is actually using the extra denoising passes. So you'll notice there's another denoising data. So there's actually two. There's denoising and there's denoising data. Denoising data gives you 3 extra passes and is responsible for perhaps the largest amount of data that gets added to any image file. What you do get though is you get extra accuracy. So you can see here we've got image, normal and albedo. So the denoising normal and the denoising albedo we're not using depth today. And I can show you what that looks like. Now I'm going to jump between using just denoising and denoising data. And you see as I'm jumping, the image is barely changing. So the addition of denoising at albedo normal really only makes a difference in some cases. You can actually see, if I zoom right in here on this reflection, you can see that as I jump back and forth between just using denoising and using the denoising data passes, that there is a little bit of a shimmer in this reflection. So when it comes to things like reflections, you might want to use the denoising normal and albedo passes just to get a more accurate result. You may happen to be perfectly happy with just the denoising pass, and you don't need to add all that extra data to your image files, and you might also save some denoising processing time as well. By default, when you open Blender, you probably have the Eevee engine selected unless you've changed your default file. Again, ask in the comments below if you want to know how to do that. There's going to be a lot of stuff in the comments. Eevee is more like a real-time or a game engine. I've just opened up a scene from in Hubert to kind of demonstrate the point about Eevee. All of this is rendered with Eevee, by the way, in real time. So you can see I can move around the scene, all the lighting, all the textures, everything is being rendered in real time. So it's really great for doing pre-visualizations, like if you want to have a look at how your animation looks from a number of different angles. Eevee's really great for that because it's really, really fast. It's literally like being inside a game. So everything renders usually at a high frame rate, although my frame rate at the moment is kind of only around 20 frames a second. Depends on exactly how much stuff you've got in the scene as to what frame rate you get, but generally this is a lot better than having to render and wait for hours to see stuff rendered in cycles. You might eventually render 2 cycles, and generally there's kind of 2 schools of thought. A lot of people I've talked to really love Eevee and work exclusively in it, and a lot of people have tried Eevee and find it frustrating and prefer to use cycles just because they think cycles gives a better result. Really, it's up to you. Eevee gives you speed, but there's a lot of prep work you have to do to get there and make it look the way you want to look. Cycles gives you really nice results fairly easily, but then you have to have quite a lot of rendering horsepower. So I've just jumped into a different file. This is another demo from blender.org, and you can see who it's created by up here. So if you want to go and download this file yourself, check the links in the description below. This project uses cycles. Now, cycles is what's known as a path tracing, or more generally a ray tracing engine. It simulates light bouncing around, and it can do some, pretty cool stuff. So it can do, for example, realistic reflections. It can do global illumination, it can do refraction, it can do caustics. It does all of the really photorealistic stuff. The only downside is it can get really, really slow. So photorealism, or really nice lighting, or a really easy way to get to nice lighting is cycles, but you pay for it in time. It takes a long time for renders to actually complete. I want to say a quick word about viewport rendering versus rendering to a file. So far I've showed you mostly rendering to a file, with the exception of Eevee and Ian Hubert's tugboat scene, which is viewport rendering using Eevee. You can also do viewport rendering with cycles. And the reason why we do this, as I mentioned before, is so that you can check out how things look. You can make some changes. It's much, much easier to make those changes when you can see how everything is kind of going to look in the final render. Now, you obviously want to do that nice and quick. I've just rendered this image, and you can see that it's taken about 9 minutes to render. So you don't really want to be waiting 9 minutes in between changes. So that's why having a rendered viewport can actually be really, really handy. So to turn on the rendered viewport, you go up to the 3D viewport and find this button here, viewport shading. Once you click that, this may take quite a long time the first time you do it. So for me, with this scene, it took about maybe 4 or 5 minutes to load. Then, once it's loaded, you can actually zip around the scene and check things out and make changes. So I can select objects and I can move them around, and the lighting will update in real time. You can see it casting shadows on the floor there. Viewport rendering, really, really handy for pre-visualization before you're going to render your final image or your final animation. Just helps you make sure that everything is actually going to be rendered properly, because you may not spot a mistake until all the colors, textures, and everything else are actually rendered. So let me show you how to control this, by the way, because there are separate controls for viewport rendering versus rendering to a file. Come across to Blender's render properties window, and then we can see we've got the choice of engine, which I've selected to cycles, and then we've also got things like sampling, which has different settings for the viewport and the render. So generally you want to set the viewport settings to something where it's actually quite fast, so you're not going to be lagging when you're moving around. Let's just say you want to move around the scene, so I'm going to press Ctrl and Shift on my middle mouse button, and I'm going to start moving around the scene. We want the update to be nice and quick so that we can easily manipulate objects and that we can easily make changes without having to wait an obscenely long time for things to update. So we can do things like setting a higher noise threshold, for example. I can set a noise threshold of 1, which means the image is probably going to be quite noisy, but it should update fairly quickly. We can also do things like lower the maximum amount of samples. Samples makes things slower. The more samples you have, the better the image looks, but the slower it renders. There's also things like denoising. We can turn off denoising. That will make it quicker. As you can see, it's a heck of a lot quicker to pan around now, but then you do have the problem of there is a lot of noise. But you may prefer the responsiveness of being able to zip around quite quickly and then just wait for the samples to fill in, as opposed to if you stick denoising on, then it takes quite a while. In terms of hardware, it does help if you have a graphics card that can support optics, because then we can actually choose optics for denoising, and as you can see, that is actually quite a bit quicker. There are also a few other settings that you can fiddle around with, but generally I think this is a good starting point. Now, when you want to start optimizing rendering to file, you'll use the render controls down here instead. Just bear in mind that this section controls viewport rendering only. This section down here controls rendering to a file. Right, so let's have a quick look at the most influential factors that control render time. First up, resolution. Your render engine has to calculate the color of every pixel in the image, and the more of them there are, the more your computer is like, okay, well maybe not like that, but think about this. If you go from 1080p to 4K, you're doubling the horizontal resolution, but you're actually timesing the number of pixels by 4. Going up to 8K, now guess what? You've got 16 times the number of pixels to render. This is why AI upscalers are so popular, because you can get 4K and maybe 8K images without having to render them, which would take 4 and maybe 16 times as long. So resolution is a really huge one. You can take advantage of AI upscaling, or if you really need 4K with all the detail, expect to just take 4 times longer to render each frame. Another thing that can affect rendering is mesh densities. If you have lots and lots of meshes, or a mesh with a lot of vertices and faces and edges, this is going to take a long time to render. This is why sometimes people use low poly models if they're not right close up to the camera, because they're going to save things like memory and time, and generally you'll have a much better render experience. Things like textures can have an effect in 2 ways. Firstly, a texture has to be loaded from the hard disk into the render engine to actually be drawn. So the bigger the textures that you use, the longer that process takes. Also, they take up space. If your system memory or your GPU memory is consumed, then your render could either run extraordinarily slowly, or the render could just crash. This is why people use things like texture atlases or compressed textures, or just try and use the lowest resolution possible. The number of samples you use obviously has a very direct impact on the render time. Thankfully, Cycles has adaptive sampling, which means that you can actually tell Blender, hey, I want the image to be no more noisy than this, and it will stop rendering each individual pixel when it reaches that threshold. This is what noise threshold is, so it's a good idea to experiment with the noise threshold for your project. Find a noise threshold that you're happy with, because that's going to save you quite a lot of render time. There are other options that you can use, such as the maximum amount of samples. You can basically specify that you don't want to go over a certain number of samples no matter what, although you may end up with a lot of noise in your image. So if you're rendering to file, Blender also has a useful option called time limit, which means each frame will only render to the number of seconds that you specify. So I gave Blender a time limit of 10 seconds to render this image, and you can see it is quite a lot noisier than the previous one. Also note the time was actually 14 seconds, and that's not 10 seconds. Just so happens in this scene that the synchronization part of the render is around about 4.5 seconds. So although it limits the drawing part to 10 seconds, it can't actually limit the part where it's loading everything into Blender. One thing I think I need to explain as well is that engines like Cycles and Eevee, the render time is actually made up of 2 distinct chunks. The first chunk is loading everything into memory and getting it ready to draw pixels. And the second part is what you're familiar with when you see Blender actually drawing pixels, like you can see here on the screen, and you can see the image slowly developing over time. Or in the case of Eevee, it's drawn more or less in real time. So some of the optimizations you're going to do will affect one of those 2, some will affect both. But it's just really important to understand that sometimes you may be saving time loading everything into Cycles or Eevee to get it to render. Sometimes you'll be saving the time when the render engine is actually drawing. And to give you a bit of an idea about what exactly is happening during the synchronization portion of the render, you can actually view it here. This is output from a render that I've done, and you can see here there's various things which will actually show up in the image editor when the render is happening. It's just sometimes they go by too fast for you to read them. So you can see things like waiting for render to start, updating scene, shaders, procedurals, background, camera, etc. BVH building. It's only when we get down to here where you see the first mention of samples that we're actually starting to draw visible pixels. So all of the synchronization part of a render can sometimes take quite a long time, and you can optimize that by doing things like reducing the amount of complexity in your scene, so removing meshes that you don't need, getting rid of things which aren't visible. Anything that could be loaded into memory that you could save that doesn't need to be in the scene, you can move out. Well, we've come to the end of how to render in Blender. Hopefully that's given you enough of an appetite to dig into the rendering part of making an animation or a still piece of digital art and try optimizing something. Like anything, it's a skill. The more you practice, the better you get at it, and you'll learn a ton about how to produce digital art, hopefully in a more optimal and less painful way, because the last thing you want to be is like this guy. Before I close, I would say I would love your comments. More than liking, sharing, and subscribing, what really helps us is if you let us know if we're doing a good job. If you think we could have done better on a particular issue, please let us know about it. If you think there's something that you would like to see in the next video that we didn't do in this one, also let us know. And that's pretty much it. So until we meet again, see you later.